Hello, Lancers. It's Mr. English, and today's lesson is what are substances and mixtures? Yesterday's lesson ended with a reading from um, an example of different compounds in the world around us was going out to the Santa Cruz Channel Island off the coast of California. And in the reading, they described the different compounds that make up the ocean, water, and some of the different rocks and plants and wildlife that exist on Santa Cruz Channel Island. It's a beautiful island, and I hope all of you get a chance to go there someday. And so today's lesson is talking about how if we don't know the compounds that make something up, we can use the word substance to describe that form of matter. And then compounds make up the world around us in the form of mixtures. It's not always just one compound of elements that makes up the rocks around us. So here's a couple examples, and I'll go into more detail as we go through the slides. I thought this diagram did a great job of differentiating between atoms, molecules, and compounds. And we'll be working out of our science notebooks today, so you'll want to have that. And the new definition, the first definition that we're adding to pages C2 and C3 is the word substance. Substance is a form of matter that is consistent throughout. Well, what does it mean to be consistent? It means that if I have a liquid, a solid, or a gas, that if I take a molecule of that matter and it's uniform throughout, that I can pull a molecule of sugar in this example, and if I were to compare this one to this one, they would be the exact same, which is represented by this chemical formula, C12H22O11. As long as there isn't salt mixed in with there, this is considered a pure substance. It's sugar. The same could be said about chlorine gas. So this is a beaker of chlorine gas, and as long as I were to pull a atom from anywhere in this container, there's no other gases mixed in there, and I compared them up against the other molecule of chlorine gas, and the formula for chlorine gas is Cl2. As long as they're the exact same molecule from anywhere throughout this sample, this is called a substance. It's chlorine. CO2, which is dry ice, which is CO2 in its solid state. And it looks like my picture got cut off here. I can move that up for you. We have sodium in its solid state. So all of these can be considered substances. Once we figure out what compounds are in them, we can write them out as a chemical formula. But if I just knew that it was a solid or a liquid or a gas, I might say, what's in that substance? And then we could test it chemically and determine what compounds make up that substance. And the same is true whether it's a solid, a liquid, or a gas. So the other examples that we have here are water. As long as in that water bottle it hasn't been mixed with salt or any other type of liquid, then this would be considered a pure substance. It's H2O. The next example, the next definition we're going to add to our science notebook is the word mixture. So a mixture is a material that's made up of two or more substances and they're physically combined. The key word to recognize here is that they're just physically combined. They're not chemically bonded to one another. So in this example, I have some glass of water that I pulled out of Laguna Lake. I took this picture there yesterday. And it's a mixture of water and algae. I can separate these back out by sending them through a filtration system. So I could have my beginning substances of pure water and pure algae, or they could be sharing the same space together, and that's when we call it a mixture. Now, you could have mixtures of compounds. So, for example, if I had water and I had toothpaste, which we looked at the other day, which is a compound, has sodium fluoride and potassium nitrate and other compounds mixed in it. And as long as I can separate them out, I haven't chemically bonded them to one another, it's considered a mixture. As soon as we start doing things and we add energy and we melt things down, and we form chemical bonds between the substances, then that's when we have compounds. So other examples of mixtures would be lemonade, which is a great example. It's water, lemon juice, and sugar. And as we get into the hotter months of summer, that would be a nice refreshing beverage. Other examples of mixtures would be chocolate milk. So this powder for the chocolate part of it is made from a tree, and the cacao pods are harvested, fermented, dried, ground up, and then we mix this with milk from a cow. And if we really wanted to, we could physically separate those back out by just allowing them time to settle, or we could use filtration to separate the chocolate powder from the milk. And physically sorting out your mixture is another example. If you have some solids that have been mixed together like this party mix, so I could pick and choose the pretzels away from the Chex Mix. And that's another example of a physical mixture. Some of the mixtures that we see in the natural world you read about in the reading yesterday. So the salt water was a mixture of trace minerals, chlorine, sodium, and hydrogen and oxygen. They consider it a compound, but compounds can be parts of mixtures. So there's water and salt to make seawater, water and soil. When you water, a garden bed, that soil absorbs the moisture, and as it evaporates out, it's a physical mixture. So you're left with the soil, the water has evaporated away, or the plant has taken it up in its roots. Tree trunks are mixtures of compounds. Plants that give off aromas like roses and other flowering plants, they have mixtures of compounds which make them smell good. We're going to be working out of our science notebook over the next couple of slides, and I found that it's useful if you do two things. First, you arrange the science notebook so that way it's in landscape. So you have the holes that are punched towards you, facing towards you. We're working on page C8, and the title is going to be Elements, Molecules, and Compounds. And on this page, I'd like to suggest that you write the words first and then draw the box around the word. And we're going to start with the word element. Oops. Oh, okay. We'll go elements first. So elements are unique in that they have a unique type of atom, and it's determined by the number of protons in the nucleus. All of them that have been discovered so far are listed on the periodic table of elements. The analogy I like to use is that it's like one of the ingredients for a recipe. So it could be the flour or the sugar or the butter. And if you think about those ingredients, some of them are like each other, but butter is not like salt, or butter is not like flour. They're very different. They have very unique qualities. And so each of these elements can be somewhat similar, or they can be very different. The other analogy that you can use for an element when you think about the elements is that they're like a single brick. It's going to be unique, but it's the building block for some of the larger things that we see in this world. A molecule are two or more atoms of the same element bonded together. And it's written as a chemical formula. For example, O3, N2, or H2. And the analogy we use for molecules is that they are multiple bricks that have been bonded together. In this mortar between the bricks are the chemical bonds that hold molecules together. The third box we're going to draw into our flow chart are compounds. Now, compounds are special types of molecules that have different types of atoms of elements bonded together. They're written as a chemical formula as well. And the examples are H2O, NaHCO3, NaCl, N2O. And the analogy here is that you can have compounds that are made up of different elements, right? And so each one of these different bricks represents a different element, and the mortar between them chemically bonds them together. And Lastly, we have mixtures. So our definition for a mixture is two or more substances together, but not chemically bonded together. And the arrows are there to show you that mixtures can be made up of elements and compounds, or elements and elements, or molecules and elements, or a little bit of all three, right? So the ocean water that they talk about in the reading was a mixture of H2 and O and NaCl, right? So it's hydrogen, oxygen, and salt to make salt water. And if you think about some of the rocks that you've probably seen out on Bishop's Peak or anywhere else, you might see a mixture of volcanic rock with sedimentary rock. And those are not going to be chemically the same. And they are simply physically bonded together, but not chemically. So they can be separated out by physically breaking them apart. They might be sharing the same space, but they're not sharing any chemical bonds. And a basic example of a mixture would be chocolate milk or lemonade. So that's it for today's lesson. Once you've copied down this flowchart, you'll want to check in Google Classroom to see what your instructor is asking you to do in addition to watching today's video. And I appreciate your time, and I hope you have a wonderful day. Thanks.